Welcome to another episode of School on Air. This is basic science for JSS 2. And today's topic, we'll be talking about work, energy, and power. Work, energy, and power. Work, energy, and power are interrelated. When you walk, play, and dance, you are working. But to do these activities, you also need energy. Power is the rate of doing work. So in this topic, you will learn the meaning of work, energy, and power, and be able to solve calculations on them. So the first one is work. What is work? The work done on an object is the product of the average force applied on the object and the distance traveled in the direction of that force. The work done on an object, how you know the work done on an object is the average. Let's start again, please. Or should I just pause here? What? Should I start from where I stopped?
Start from work.
Start from work.
Speak up. Work. Action.
Now, let's go to work. The work done on an object is the product of the average force applied on the object and the distance traveled in the direction of the force. I'll take that again. The work done on an object is the product of the average force applied on the object and the distance traveled in the direction of the force. Now, this implies that work, which is W, is equals to force times distance. Work is equals to what? Force times distance. Now, the SI unit of work is joule, which is symbolized by J, joule. So you can say that joule is equals to force times distance. Now, when you lift an object, you are doing work by using force to move that object from one position to the other. That is distance, right? Good. Now you will recall that the unit of force is Newton and the unit of distance is what? Meter. So back to the formula for work, you can say that work is force times distance, meaning work is equals to Newton times meter. Newton times meter. So let's look at those formulas. W is equals to FD, where W is work, F is force, and D is distance. You can also represent it as joule is equals to Newton times meter, or in the shorter form, J is equals to Nm. Now let's solve this together. What is the work done in lifting a log of wood through a distance of 25 meters if 30 Newton of force is applied? What is the work done? We want to look for the work done. What is the work done in lifting a log of wood through a distance of 25 meters if 30 units of work, Newton of force, is applied? Now, we know that work is force times distance, right? Good. Now, what is force? 30 Newton, as it is given to us in that equation. Force is equals to what? 30 units. While distance is equals to what? 25 meters. So to calculate work, you would say 30 Newton times 25 meters. 30 Newton times 25 meters. That will give you 750 Nm, which is the same thing as 750 joules. So the work done in that equation is 750 joules. Now, let's look at this, the second one. A 50 kg bag of rice is lifted through a distance of 7 meters. What is the work done in lifting the bag of rice if you take the gravity, that is G, to be 9.8 meters per second? I'll take the question again. A 50 kg bag of rice is lifted through a distance of 7 meters. What is the work done in lifting that bag of rice if the gravity is 9.8 meters per second? Now you know that